question, it has a diagram. The diagram includes a disk with a radius r, with mass on the end of it, with mass m, and the mass falls down a distance d to the ground. The first question is calculate the acceleration of the block. Okay, so we're going to use kinematics for this. So we're going to use the equation change in y is equal to the velocity of the block initial times time plus 1/2 acceleration of the block times time squared. And we're going to solve for acceleration of y. But let's substitute in the variables we know using the diagram. So the change in y will be d, and because the block starts at rest, the velocity is 0, so then that means this whole section is 0. So we can just move on to 1/2 a t squared, and then we're solving for y, so we'll multiply by 2 on both sides. 2d is equal to a t squared, and divide by t squared on both sides. So the acceleration of the block is equal to 2 times the distance over the time squared. Part B of this question has 3 parts. The first part is, how could the variables used in part A be graphed to get acceleration using best fit line? This is asking us to get a linear trend. So we are going to need the equation we got in part A, which was a y is equal to 2d over t squared. But let's use the earlier equation that we got, which was d is equal to 1/2 a t squared. Because if you notice, this is already in the y equals mx form. D will be our y, and because we want the acceleration to be in our slope, because that's what we want, we'll have that as m, and then t squared will be our x. So what we need to graph for a linear slope will be t squared and d. So to graph d and t squared. So let's solve for t squared. So now we can graph it. So on the x-axis we would have t squared, and on the y-axis we would have d. Let's break it up into sections. 0.5, 1.5, 2, 0.5, 1.5, and 2. So to graph d and t squared. So let's solve for t squared. That would be, for 0.68 it would be 0.46. For 1.02 that would be 1.04. For 1.19 that would be 1.41. And for 1.41 that would be 1.99. Rounded to the nearest hundredth. So now we can graph it. So on the x-axis we would have t squared, and on the y-axis we would have d. So our first point will be 1.46 to 0.5. Right around here. Our second point will be 1.41 0.04 to 1. That'll be like right here. And our next point will be 1.41 to 1.5. 0.41, 1.5. And our last point will be 1.99 to 2. 0.99 2. And our best fit line will be right around there. And this line will equal A over 2. Now part 3 of B is use your graph to calculate the magnitude of the acceleration. So we're going to need to find the slope of our best fit line. And because the slope is the acceleration, we can use slope is equal to the change in y over the change in x. So we can use the change in y and the change in x. So that will equal 2 minus 0.5 over 1.99 minus 0.46, which would give us 1.5 over 1.53, which equals 0.96. So because the slope is 0.96 and 1/2 a equals the slope, we know that a is equal to 1.92 meters per second squared.